All right, so today we're going to work on linear inequalities, which is section 1.6. I've got a variety of examples here for us to work out. So let's get started. For the first one, we're going to do 7w minus 3 is greater than or equal to 9 plus 9w. We want to make sure that we answer with interval notation, and the directions here say to use a decimal form if needed. So we're pretty much going to treat this like an equal sign. Unless we have to divide or multiply by a negative number, then we switch the sign. So I'm going to start off by subtracting 7w from each side to cancel the w's, and this will keep my variable coefficient positive, which is what I prefer. You don't have to do that first step. You could add 3 to both sides if you wanted. Next, I'm going to subtract 9 from both sides. So that'll give me a negative 12 is greater than or equal to 2w. Divide by 2. So this is negative 6 is greater than or equal to w. Now a lot of times when we graph these, we're used to seeing the variable on the left-hand side. So I'm going to switch this around before I graph. And when I do that, I'll write the variable on the left-hand side. I'll also have to switch the inequality symbol, so that'll be less than or equal to negative 6. All right, so here's my answer. Now I need to represent it on a number line and an interval notation. I prefer to graph first, so I'm just going to put a negative 6 on my number line. I'm going to use a bracket since we are or equal to. And I'm going to open that up to the left since we are less than, and we are shading to the left towards negative infinity. And this right here basically sets up our interval notation too. My interval notation will be negative infinity to negative 6 with a bracket. And with infinities, we always use a parenthesis. So there's our answer, and there's our answer for that one. All right, number 2, consider the following linear inequality. We need to solve, same directions as last time basically. All right, so one thing we want to try to do is probably get rid of the decimals, or excuse me, the fractions. So what we're going to do is, with big parentheses on each side, I'm going to multiply each side by 9. And what that allows to happen is this 9 will cancel with that 9. Okay. So then I have 8x plus 2.6 is greater than. Now this 9 will need to get distributed right here. So I'll have 7x times 9. So that'll give me 63. X plus 1.2 times 9 is 10.8. And that side is still over 8. Okay, that just canceled the 9. Well, now we're going to pretty much do the same thing, except for multiply by 8 on both sides. And you can do that in one step if you want to. Now these 8's over here will cancel. And on the left-hand side, this 8 will need to be distributed. Okay, so now we'll have 64x plus 8 times 2.6, which is 20.8, is greater than 63x plus 10.8. All right, so now this kind of looks like our previous problem. We still do have some decimals, but that's all right. I'm going to subtract 63x from each side. This will keep my variable positive. 64x minus 63x is 1x, but I will just write that as x. Plus 20.8 is greater than 10.8. Now I'm going to subtract 20.8 from each side. So I'll have x is greater than negative 10. Okay, so here's my answer. Now I need to put it on an interval and a number line. So I'm going to start my number line with negative 10 somewhere. I'm going to use a parenthesis this time since it's just greater than, not greater than or equal to, so parenthesis. And I want to shade towards the right, towards positive infinity since I'm greater than. So again, this pretty much sets up my interval notation. I'm going to go from parenthesis negative 10 to infinity, and always use parenthesis with infinity. There we go. All right, number 3, we have our first compound inequality. So what I'm going to do is focus on just getting x left in the numerator. So the first thing I'm going to do is multiply all 3 parts by negative 4. So when we multiply by -4, we'll have to flip both of these inequality symbols. So I'm going to go ahead and do that while I'm thinking about it. Now, these -4s will cancel and leave us with just x plus 2 in the middle. Positive 0.5 times -4 is -2. And -0.5 times -4 is +2. Okay? Then we're going to subtract 2 from all three places. 2's cancel in the middle. This becomes 0 is greater than or equal to x is greater than or equal to -4. Now, a lot of times when we have to switch signs and these types of problems, I notice that my smaller number is actually on the right-hand side, which doesn't make sense. So what I'm going to do is I'm going to flip this guy around. When I flip it around, I need to make sure I also flip my inequality symbols. Okay, so now when I graph this, I'm between -4 and 0. I have bracket, bracket, and I'm shading in the middle. Brackets because we're or equal to. And this pretty much sets up our interval notation, bracket -4, comma 0. All right, for number 4. So step 1 says solve the first inequality, so let's focus on that one. I'm going to start off by getting rid of the denominator, so I'm going to multiply each side by 4. So that leaves me with 4y plus 4 is greater than 36. We're going to subtract. 4y is greater than 32. Divide. Y is greater than 8. So that's my first answer. I need to make sure I use interval notation. So I'm just going to do parenthesis 8 to infinity. For the second one, I'm going to, you have two choices here. You can divide by -6 or you can distribute. I'm going to go ahead and divide by -6 on each side. 6's cancel and leave me with y minus 2. Since I'm dividing by a negative number, I'm going to flip that inequality sign and say that's -10. I'm going to add 2 to both sides. Y is less than -8. So my second answer will be from -infinity to -8. Solve the overall problem. So when I think about this, I've basically got from -infinity to -8, and then again from +8 to +infinity. So I've got a gap in between here that is not part of my answer. So when I write that in interval notation, it'll be from -infinity. Oh, excuse me. This is an and problem. Okay, there's no overlap in what we have. So the answer for this one is actually no solution. There are no numbers that are less than -8 and greater than +8. So since there's no overlap here, this is a no solution problem. For the next one, or. All right, so we're going to solve the first one. I'm going to divide each side by -3. Y minus 1 is greater than or equal to -7. We're doing a little switch on the symbol. Add 1. Y is greater than or equal to -6. So there's my first one. I'm going to start at -6 with a bracket since I'm or equal to and go to infinity. For the second one, this is a one-step problem. We're subtracting 12. Y is less than 8. Okay, so that is from -infinity to 8. So I'm going to graph this first and then answer number 3. The first one is from -6, so I'm just going to pick a spot for -6, bracket, and I'm shading all the way to the right. The second one, I'm going to find a place that looks like it could be 8. And parenthesis, I'm shading all the way to the left. All right, and I'm going to look at my wording up here. The wording is or. So as long as a number is an answer to one or the other, it's an answer to the whole thing. And if I look at my inequality line, it's completely shaded everywhere. So our answer to this guy is all real numbers. In interval notation, that's -infinity to infinity. Okay, if the wording would have been and, then our answer would have been -6 to 8, because it would need to be the numbers where they're both shaded. All right, now we're getting into some absolute values with inequalities. So for number 6 here, we're going to solve. It's a gray-tor problem, so typically our answer will look like an OR. I'm going to divide by 5, and I'll have the absolute value of x plus 1 is greater than 7. Okay, so since this is an OR, I need to figure out my two inequalities to solve. My first one is going to be just the way it's written here without my absolute value symbols. Or then I'm going to write the same term that's on the inside of the absolute value sign, switch the sign, and make the number negative. There's my second one. So I'm going to subtract 1 and subtract 1. Okay, so here's my answer. X is greater than 6, so I'm going to graph this first. So I'm going to find 6 parenthesis greater or less than negative 8. All right, so in interval notation, that'll look like negative infinity to negative 8 union 6 to infinity. Okay, so again, if it's a gray-tor, that's an OR problem. We flip the sign and make that negative for our second equation. All right, number 7. So same directions here. First thing I'm going to do is subtract 5 from each side. So now I have negative absolute value of 2 minus 4w is greater than negative 20. I'm going to divide by negative 1 to get that negative right there to cancel. And when I do that, I need to flip my sign. So now I'm less than, and this is a positive 20. So if we have a less than symbol, we are going to take this 20, plop it on the other side and make it negative, and keep the symbol the same and make a compound inequality. So it'll look like this. Negative 20 is less than 2 minus 4w is less than positive 20. We're going to solve like normal. So subtracting 2 everywhere. So that's negative 22, negative 4w, and 18. I'm going to divide by negative 4. All right. So negative divided by a negative is a positive. I'm going to reduce that fraction to 11 over 2. Since I'm dividing by a negative, I need to switch my signs. So greater than, plain old W, greater than. This reduced fraction would be negative 9 over 2. Okay, so there we have it. I'm noticing my negative number is on the right, so I'm going to take this guy and flip it around. So negative 9 over 2. When I do this, I need to flip my signs also. Less than W, less than 11 over 2. I'm going to write it like that. Okay, so negative 9 over 2, 11 over 2, and shading between. So in interval notation, there we go. I just seeing it says use decimals, so that'll be negative 4.5 and 5.5 as opposed to the fractions. Okay.